Hello, ladies and gentlemen. Welcome back. It's day 2 without Mr. Massey, but is that going to stop us from learning? Heck no. So let's continue to learn about some chemical reactions. This time we're going to work on Intro to Chemical Reactions, which means we'll take a look at some chemical reactions and we'll learn about how we can use language, how we can use naming that we've learned earlier in the year, last semester, and apply it to these reactions. That way we can all be on the same page when we're talking about different reactions and we know how to talk about them. So let's get started. So this first example right here, this is the first example of a chemical reaction that we'll look at. So we can see here, this first example has a bunch of formulas. We can see a bunch of symbols, and remember, we can follow our naming principles to name these. So hopefully you guys remember this from last semester, but I've written a flowchart down like this before. Remember, we always have to start with whether it's ionic or covalent. Then we can determine what's in the formula, whether it's a compound or a molecule. Compounds have a metal and a nonmetal. Covalent have two nonmetals. And then remember, covalent, we have prefixes. Those prefixes equal the subscripts. In ionic, we have to try to determine what we have present and then follow the appropriate rules. So remember, in an ionic, you can have a positive ion and the name stays the same. You can have a negative ion from the periodic table, that ending just turns to "ide." You can have a polyatomic ion, which we'll use inside of parentheses. Polyatomic ions, we just use that given name that's on that list that you have, that's on the back of the periodic table that I handed out. Then we also can have a transition metal. Transition metals, they're located in columns 3 through 12, and we use Roman numerals. Those Roman numerals, they tell us the charge of the transition metal. Remember that, charge of the transition metal. Anytime you have an ionic compound, you will have to use the crisscross method. I'll review the crisscross method a little bit later in this video. I'll help you out, guys, and I'll tell you, on this worksheet, we have no examples of covalent molecules. Covalent molecules are typically not used in single replacement and double replacement reactions, which a lot of this worksheet will be using because they tend to be a little bit trickier. So we'll practice with the trickiest ones and then hopefully we'll get easier as we go. So we're not going to be using prefixes at any point on this worksheet. So you will be using the crisscross method and you will have to analyze the formulas and the names to determine what you have present, whether it's just on the periodic table, a polyatomic ion, or a transition metal. So let's get started. So let's look at this first example that's up here. So we see, oh, that's the wrong sheet. That one's got all the answers on it. So we'll look over here and let's now look at the one we'll take notes on. So we see here, so right here, this is the formula. Beneath it is a sentence that describes it. It tells us copper 2 nitrate reacts with zinc metal and yields zinc 2 nitrate and copper 2 metal. You may have already noticed that I did color code it a little bit to kind of help guide our thinking. So everything that's in this sentence correlates to the reaction that we see in front of us. So we'll see here that copper 2 nitrate, that's copper 2 nitrate right there. Reacts with, that's the plus sign. Zinc metal is just referring to zinc. Zinc 2 nitrate is referring to ZnNO3 and then copper metal is just referring to copper. So when it uses the language reacts with, remember reacts with is the plus sign, yields is the arrow, and then when it uses and, that is also the plus sign. Some other language that can be used instead of yields, lots of times reactions will use the word produces instead. Yield and produce are the same. They're interchangeable. So now that we have a little bit of the basics down, let's head down to the first example and let's do question 1 together. So question 1 is asking us to look at the following reaction and write a sentence that goes with it. So essentially what we have to do is we have to name, and then we have to add the words like reacts with for the plus sign, yields or produces for the arrow, and then another plus sign it makes and. So it's not a whole lot different than the naming that we've already done. So let's give it a shot. So let's look at this first example, CaCl2. So I already told you that all of these will be ionic. It's because calcium is a metal, chlorine is a nonmetal. So now we have to analyze what we have. So let's take a look back at this flowchart right here. So we know that positive names stay the same, negatives change to "ide." So if we think about CaCl2, so if we look at all the other things that are present, we do not have a polyatomic ion because there's no parentheses and it's not multiple atoms. And then there's no transition metal because calcium is not in columns 3 through 12. So we just have to use the basic naming rules. The positive name stays the same and the negative changes to "ide." So let's take a look at it. So we'll start with CaCl2. Ca is calcium. It's positive, so we don't change the name. Chlorine is negative, so we change the ending to "ide." So that name becomes calcium chloride. Remember, this plus sign stands for reacts with, so we write reacts with. Now we have to name this thing, AgNO3. So let's go back to our flowchart. So we have to analyze what we have. So remember, we're thinking about AgNO3. So NO3 is a polyatomic ion. So if you think about it, there could be parentheses around the NO3. You also know this is a polyatomic ion because poly means multiple, atomic means atoms, and you have multiple atoms. You have an N and you have 3 oxygens. So we know this is a polyatomic ion, so we'll just use that given name. And then Ag. Ag is a transition metal. Transition metals are found in columns 3 through 12. If I remember correctly, Ag is in column 11. So that means it would be a transition metal. So with transition metals, we need to include a Roman numeral. That's that charge. So let's label this. So we know Ag, this is a transition metal. And we know NO3, this is a polyatomic ion. So let's get started with naming it. So Ag's name is silver. We know all metals are positive, so we don't change it. We do know it's a transition metal, so we have to include the charge. We'll calculate the charge in a second. And then we know NO3 is nitrate. Remember guys, polyatomic ions, we use that given name, so we don't have to change it. So it stays nitrate. Now we just need to figure out what that Roman numeral is. So we look up the polyatomic ion on our list. Nitrate has a -1 charge, so we can write -1. What that means is silver must be +1 to balance it out. So the Roman numeral becomes a 1. Then we go on to the arrow. Remember that arrow means yields. So we know we can use either yields or produces. Because we used yields up top, I'm going to use produces down here. So we'll say to produce. And now we need to name the other side. So again, we have CaNO3 too. We already determined that NO3 is a polyatomic ion, so we know we'll use the name nitrate for that. Now calcium. Calcium, it's still not a transition metal, just like in that first example, so it stays calcium. And then we combine it with nitrate. And again, remember that second plus sign, that stands for and. So then we write and. And now we just have to name that other part, AgCl. Remember guys, Ag, it's still a transition metal. So because it's still a transition metal, we need to include a Roman numeral. So we know that it's silver. We can calculate the charge. The charge of chlorine, because it's in column 17, is -1. That means our charge of silver must be +1. And then because chlorine's negative, we change the ending to ide. Becomes silver 1 chloride. So we see here that this formula is calcium chloride reacts with silver 1 nitrate to produce calcium nitrate and silver 1 chloride. So let's move on to number 2. So number 2 is now the opposite. So we're given the sentence and now we need to come up with the symbols. So remember guys, I told you that everything we're going to do on this sheet is ionic. So that means we have to use that crisscross method. So this is where we'll practice a little bit. So nickel's a transition metal. It gives us the Roman numeral. That's the charge of nickel. So we know nickel has a positive 2 charge. Nitrate. Nitrate, we just used it up in example 1. We know nitrate is a polyatomic ion. So remember, we put our polyatomic ion inside of parentheses. We put the charge on the outside. That way we always remember to never change what's on the inside. And then we crisscross. We bring the 2 to the right side. We bring the 1 to the left. Remember, we don't bring down that negative sign, because if it said -1 nickels, that doesn't make sense. You can't have a negative amount of an element. So then this formula becomes Ni. Remember, you can write the 1 or leave it blank. NO3 inside parentheses with a 2 on the outside. We know reacts with stands for a plus sign, so we write a plus. And it's going to react with sodium carbonate. So sodium, symbol is Na, has a positive 1 charge because it's in column 1. And then it reacts with carbonate. Carbonate, you find that on your polyatomic ion list. CO3 with a negative 2 charge. Then we crisscross. We bring the 1 to the right side, the 2 to the left side. Remember, we drop that negative sign because we can't have a negative amount of sodium. So then this formula becomes Na2 parentheses CO3. We learned up top that yield stands for the arrow, so we write the arrow, and then it's going to yield nickel 2 carbonate. So again, let's crisscross. Nickel's transition metal, Roman numerals 2, so it has a positive 2 charge. Carbonate, polyatomic ion, CO3 with a negative 2. We put the carbonate inside of parentheses. We crisscross. We see here that the charges are the same, so that means the subscripts cancel out and we reduce them to 1s. So it becomes NiCO3. And then that last part is sodium nitrate. Again, we have to crisscross. Sodium still has a positive 1 charge. Nitrate is still NO3. We put it inside parentheses and the negative 1 charge on the outside. And now we crisscross. We bring the 1 to the left side, bring the 1 to the right side. We realize they're both 1s, so we don't have to write them. Because NaNO3. And that's how you do this. We just apply name in, and then we relate it back to reacts with stands for the plus sign, yields or produces stands for the arrow, and then the and stands for the other plus side on the product side. So hopefully this will take you through the rest of the page and the few examples that you do have to work on. If you do have any questions, please write them down. Don't just simply tell me I didn't know how to do it. Think about the process and write down a question. If you write down a question, that will earn you credit, because then I know what I have to do to help you when I come back to class. Just like last time, I want to leave you with a joke. So if you guys didn't know this, I'm a big Harry Potter fan. Harry Potter came out when I was in elementary school, and I have very fond memories reading it with my mom. So here's a Harry Potter joke for you. How did Harry Potter get down the hill? Walking. Nah, JK, he was rolling. Hope everyone has a great day. I'll see you when I return. Bye.